Hello, so today's lesson is on exponential applications. If you're in my class, and you should be on page 13 of your note packet. So we're going to suppose that you start a job and you're making $40,000 as an annual salary per year, and you receive a 4% raise at the end of each year. How much would you make after 1 year on the job? Well, there's several ways that you could do this. The first thing that I might think of is what is 4% of 40,000? To find 4% of 40,000, you would turn the percent into a decimal, which is 0.04. Anytime we want to turn a percent into a decimal, we move 2 decimal places. So that was from here, 2 decimal places. So I could do 40,000. I could multiply that by 0.04, and that would give me 1,600. But that's not how much I'd be making each year. That would be my raise. So then I'd physically have to take the 40,000 and add 1,600 to it, which would give me 41,600. That's one way of doing it. An easier way of doing it is to think about what we did back when we were talking about the value of a coupon going up or down or a percentage off. You can actually take the 40,000, okay, and you could multiply it times 1.04, meaning 104%. That means it's going to include the 40,000 and the 4% and get you directly to your answer. So if you do that on your calculator, let's verify, and we'd get 40,000 times 1.04, which gets me directly to the amount I'd be making at the end of the year, $41,600. So this is just an easier way of doing it. Let's keep going though. How much will you be making 2 years on the job? All right, now this is a different question because I have to take the 41,600 I now make in the second year, and now I have to multiply that by 1.04. I do that, and I'll get $43,264. I can't just start with the original amount because I made more the next year, so that 4% is on an increased amount. All right, how much will you be making 10 years on the job? Do you really want to have to find 3 years, and then 4 years, and then 5 years, and then 6 years, and then 7 years, and then 8 years, and then 9 years, and then 10 years? Do you want to have to go through all that work? I say no, okay? This is where an exponential application can help, okay? And when we think about an exponential application, it's basically thinking of a formula. How much will you be making n years on the job, meaning an unknown years? Could you put in your original salary, know that you're going to get a 4% increase per year, and decide in 10 years how much you could possibly be making? All right. So let's talk about exponential functions. Example 1 is an example of exponential function because the value is increasing exponentially and not at a constant rate. When a value increases or decreases by a percentage, the function's exponential, and it can be modeled by a model in the form a at t is equal to a sub 0, 1 plus or minus r to the t. Yes, it's a funky function, but it's actually quite easy. You're going to see how easy it is once we start doing examples. A sub 0 relates to the initial amount, the starting value, the initial amount. R is the rate, which is a percent, but we are always going to express as a decimal. And remember, when we turn a percent into a decimal, we need to move it 2 places. We move the decimal 2 places. So if it's 4%, then we move the decimal from here 2 places. So it would be, as a decimal, it would be 0.04. Okay? And t is the time. Okay. Now, notice that there's a plus minus in the formula. The rate could be negative if the initial value is decreasing, meaning it's going down. So if it's decreasing, some words I might look for would be decreasing or losing value. Or even if the graph is declining, an exponential graph declining would look something like that. Exponential decay. That would tell me that I'm losing value. All right, so let's look at an example. Suppose a hamburger is $4 and has been increasing at the rate of 9% per year. Use the model to find the cost of the hamburger. Okay, so our model, it's going up, it's increasing. So my model is going to be A at t, okay? A at t is equal to A sub 0 times 1 plus r, because it's increasing, to the t power. All right. So in this case, it says find the cost. So instead of A, I'm actually going to use C. So C at t equals my initial value, $4, 1 plus 9%. I need to turn that percent into a decimal, so 0.09 to the t power. I'm going to simplify that. So 4 times 1.09 to the t. Now you can see where that 1 came from in that example earlier with the 40,000. I'm adding 1 to it because it's basically going to multiply 4 times the 1 and 4 times the 09, okay? All right, so then that's our model. So our model is C at t equals 4 times 1.09 to the t power. Then the question asks, what's the value 5 years from now? That means let t be 5, so C at 5. So we plug it in. 4 times 1.09 to the 5 power, and we stop. Because we want to be really careful here. We have to follow proper order of operations. We cannot multiply the 4 to the 1.09. We have to do exponents before multiplication. So I have to do this part first. Okay, so let's grab those calculators. Okay, and we're going to do 1.09 to the 5 power, making sure we know how to raise a number to the 5 power. Let me clear. So 1.09 raised to, we're going to use the caret, which is right under the clear button, to the 5 power times 4. And we get $6.15. So we will round that. So that will be $6.15. All right, let's do another example. The population, so next page, the population of a city is currently 200,000 people. The population is growing at an annual rate of 3%. Okay, write an equation expressing the population t years from now. So I'm going to use the P. Population at t years from now. All right, so I start with my initial value, 200,000, times 1 plus r. So I'm going to turn 3% into 0.03. So 1 plus r is going to give me 1.03 to the t power. There's my model. Find the population 10 years from now. So that's saying let's let the time be 10. Okay, so we do 200,000 times 1.03 to the 10 power. We're very careful. We can't multiply the 200,000 times the 1.03. We have to follow order of operations. This has to come first. So let's try that on our calculator. We get 1.03 raised to the 10 power times 200,000. And so the population will round because we're going to round to people. So 268,783. Can't round up, got to round down. All right, let's look at one where it's something could be decreasing. You purchase a car for $28,000. The car loses 20% of its value each year, okay? And that's about right. Cars' values go down immediately. All right, express the value of the car T years from now. All right, so the value at T time is what I'm going to use. My initial value is 28,000. But now in this case, it's losing value, so I have to do 1 minus R. So 1 minus 20% as a decimal is 0.20, so 1 minus 0.20. All right, to the T power. I'm going to simplify that. That's going to give me 28,000 times 0.8, so 80% of the value after a year. All right, it now wants to know what the value will be 5 years from now. So we do V at 5. So 28,000 times 0.80 to the 5. So in 5 years, go ahead and put that in your calculator. Let's see what you get. 8.8 to the 5 times 28,000. Hopefully you get on your calculator $9,175. Car's not worth as much as it was 5 years ago, was it? Okay. Now let's look at the impress me. Impress me. In how many years will the value of the car be approximately half of what it is now? All right, so I'm going to do it, but if you want to try this on your own, try it on your own and then pause us and come back. So approximately half. That means half of 28. It's asking when is the value going to be 14,000? Because that's half of 28. So that means when is the value going to be or equal 14,000? So this is what I have. So I'm trying to find T. So I looked at this and I was like, oh goodness, I'm going to divide. I'm going to get rid of that 28,000. So I'm going to divide both sides by 28. When I'm allowed to do that, I'm allowed to get rid of that on both sides. And interestingly enough, you should see it simplifies. It actually simplifies to the number 1/2. So it's saying 1/2 is equal to 0.80 T. Well, I don't know how to solve something that has a variable that's an exponent. So could I just plug in numbers? And 14,000, it has to be less than 5 because after 5 years it was worth 9,000. So I just decided I was going to try the number 3. That seemed about right. So I plugged in 0.80. I put in 3 and I asked myself, does it give me 1/2? All right, so let's see. So 0.8 raised to the 3 power gives me 0.5. So about 3 years. That's about 0.5. So in about 3 years, the value will be half of what it is now. And we're going to learn later on how to solve when the exponent is a variable. But for now, all we can do is guess and check. All right, one more question. I want you to turn to page, to question number 8, which is page 16. All right, so now this one, we're going to be working with a graph, okay? All right, so our graph, I gave you some values on the graph. I gave you, 5, 10, 15, 20, 25, and 30, and 1, 2, 3, 4, 5, 6, 7. Okay, so this question basically says in January 1993, about 1,313,000, there were about this many internet hosts. During the next 5 years, the number of hosts increased by about 100% per year. Write an exponential model giving the number of hosts in T years after 1993. Okay, so now we need to remember that means that 1993 is 0 for T, okay? We did that earlier this year. So my model is going to be H at T, because it's asking for hosts at T time, 1.313, because it says in millions. I don't have to write out all the zeros, okay? 1.313 times 2 to the T. How did I get 2 to the T? Well, 100% as a decimal is 1. And 1 plus 1 is 2. So this is an interesting example here. It's basically saying that it's doubling every year. Okay, so how many hosts were there in 1996? So 1.313 times 2 to the 3 power, okay, because I want H at 3. Why? Because 1996 is 3 years from 1993, okay? If I do that, I get 10.5, okay? So there are 10,500,000 internet hosts in year 3. All right, then it says graph the model. Well, when we graph a model, we can make a table of values for ourselves. So here's what I'm going to do. I'm going to make a table of values, x, y. I'm going to do 0 because I know 0 is the y-intercept, and it was 1.313. I'm going to plug in 1. So I plug in 1 for x. So 1.313 times 2 gives me 2.626. I'm going to plug in 2. That's going to give me 5.252. And I'm going to plug in 3, and I'm going to get, what did we get? We got 10.5. I'm going to plot those points. 0, 1.3, so right about here. 1, 2.6, right about here. 2, 5.25, so maybe here. And 3, 10 point something. We know it's exponential, so we know that it's growing exponentially. If we want to estimate using the graph, well, then we go over to 30. It's like, when is there going to be 30 million hosts? And then we come down to when. And if we can kind of see, it's somewhere between 4 and 5 years. So between, in this case, from 93, 4 to 5 years from 93 would be between 1997 and 1998. So that's how you use a graph to model it and find an estimate of a value. All right, so we're going to stop there today, guys. In class tomorrow, you're going to be practicing all this, writing models and solving. And if you have any questions, again, make sure you post them to the Google Doc. Have a great night.